Periodic properties. Since the beginning of 19th century, scientists have been trying to find a basis of grouping of elements similar to their properties. Through several scientists, namely Lavoisier, Newlands, Meyer, and Mendeleev, attempted to find certain regularities among elements. The first important attempt to divide the elements on the basis of physical and chemical properties was made by German scientist Loder Meyer and Russian chemist Dmitry Mendeleev. They observed that when the elements are arranged in the order of increasing atomic weights, the elements with the similar properties reoccur at regular intervals. Mendeleev gave law as the law known as the periodic law. The law states the physical and chemical properties of elements are periodic functions and their atomic weights. The Mendeleev classification gave him so much confidence that the boldly left certain spaces or gaps for undiscovered elements. By considering the properties of the adjacent elements in the table, he predicted the properties of these undiscovered elements. Later on, when these elements were discovered, their properties were found to be exactly similar to those predicted by Mendeleev. For example, gallium and germanium were not discovered at that time when Mendeleev formulated his periodic table. He not only predicted the existence of these elements, but he also estimated there would be similar to aluminium and silicon respectively. When chemists discovered these elements, Mendeleev's prediction of their properties proved to be remarkably correct. Modern periodic law. In 1912, Moseley proved that the physical and chemical properties of the atoms of elements are determined by the atomic numbers and not by their atomic periodic atomic weights. The acceptance of atomic number are as the important characteristics of atom led to the modern periodic law, which may be stated as the physical and chemical properties of the elements are periodic function of their atomic numbers. Con- Consequently, when the elements are arranged in order of increasing atomic number, it is observed that the elements of similar properties reoccur regular intervals periodically. As a result, one of these elements fall in certain groups and led to arrangement called the periodic table. With the modern periodic law as the guiding principle, many new forms of periodic tables have been processed. However, the general plan of table remained the same as proposed by Mendeleev. Of these, the most commonly used form is known as long form of periodic law. The long form of the periodic table, position of elements in periodic table. The most widely used periodic table these days is the long form of periodic table. This is constructed on the basis of repeating electronic configuration of atoms when they are arranged in the order of increasing atomic numbers. Long form of periodic table is given or next page. Structural features of long form of periodic table. The long form of periodic table consists of horizontal rows and periods and vertical columns called groups. These are discussed below. Periods. A horizontal row. A horizontal row in the periodic table is called period in terms of electronic structure of atom. A period consists a series of elements whose atoms have been same number of electron shell. Principal quantum number n. There are 7 periods and each period starts with a different principal quantum number. Elements of first period. The first period corresponding to n is equal to 1 is unique because it contains only 2 elements, which is not surprising because first energy cell has only one orbital which can accommodate only 2 electrons. This means that there can be 2 elements in which one of the two electrons are present in first energy level. The first period contains hydrogen and helium. Elements of second period. The second period contains 8 elements because for n is equal to 2 there are 4 orbitals, 1 2s and 3 2p. In all, these 4 orbitals have a capacity of 8 electrons and therefore second period has 8 elements. It starts with lithium Z is equal to 3, in which one electron enters the 2s orbital. The period ends with neon Z is equal to 10, in which the second cell is complete 2s2 2p6. In third period corresponding to n is equal to 3, there are 9 orbitals, 1 3s, 3p and 5 3d. However, we know from energy level diagram of multi-electron atoms that 3d orbitals are higher in energy than 4s orbitals. Consequently, 3d orbitals are filled after filling 4s orbital. Hence, this period involved the filling of only 4 orbitals, 3p and 3s, and contains 8 elements from sodium to argon. Elements of fourth period. The fourth period corresponding to n is equal to 4 involves the filling of 1 4s and 3 4p orbitals. 4d and 4f orbitals are higher in energy than 5s orbitals.